Good morning, everyone. Good morning, Veena. Good morning, Kishni. How are you all? Very good. Previous class, we have discussed nuclear physics. Very good, Veena. In nuclear physics, the topics that we have covered were we have covered radioactive decay, that is alpha decay and beta decay things. Okay. So, one more thing that I will tell you, beta decay is of two types. I hope you remember. One is negative beta decay, one is positive beta decay. Can you answer me in negative beta decay, which particle is converted to what? Can anyone answer? If you remember, in negative beta decay, which particle is converted into what particle? I am on standby. Do you remember or not? Tightly bound nucleus. No, okay. The question is, in negative beta decay, which particle is transformed into what particle? For example, I told you that in negative beta decay, neutron converts to proton and one electron is ejected, plus some antineutrino and some energy is released in the process. That's what I was asking, that neutron is converted to proton and one electron is set free and it comes out of the nucleus. So one question that I will ask, that during the negative beta decay, electron is emitted from the nucleus or electron is coming out of the element. For example, I have a sample of some material from which beta particles are coming out. That means electrons are coming out. So the question that may arise is, these electrons are the electrons which were orbiting the nucleus, or this is the electron coming out from the nucleus? The answer is, the electron, the beta particle which is coming out, is coming from the nucleus, not the orbiting electron. This is not the orbiting electron. This is the electron coming from the nucleus. But someone might say that nucleus doesn't have electrons. So the electron is actually converted by the transmission or by the conversion of neutron into proton. I think statement is clear. So it should be very much clear, because the question is asked in this way, that in beta emission, electrons are coming out of the sample. So these electrons are the orbiting electrons or not? So the statement is, these are not the orbiting electrons. Clear? It may be asked in assertion region questions. Clear? So now today's topic is going to be radioactivity. What is radioactive decay law? So we will start with that. Radioactive decay law. What it says rate of decay of a radioactive sample is directly proportional to the number of undecayed nuclei. So it might be little bit of confusing if I say, let's suppose I have a sample. I have a sample of radioactive material from which alpha, beta, gamma emissions are taking place. From this sample, if I consider, let's suppose at time t equals to 0, there are n not active nuclei. There are n not active nuclei. Active nuclei means the nuclei which can be decayed, from which disintegration will going to happen. These are n naught. And at time t, they decreases to n. Now they have disintegrated. They have disintegrated. So these are the remaining number of active nuclei. I will mention these are the active nuclei. Now, further, after a very small time, some more elements are disintegrated, some more atoms or nuclei are disintegrated. Let's suppose they are, how many nuclei were disintegrated? Dn. N was originally, Dn was disintegrated, so remaining number was n minus Dn. So the statement here says, the law of radioactive decay says, the decay law says, rate of disintegration, that is dn over dt. This is rate of disintegration, or you can say minus dn over dt. Why minus dn over dt? Because minus is placed because it is showing decay. If they were increasing, then it will be positive dn over dt, because you can see that number increasing is directly proportional to the number of undecayed nuclei at that instant. So at that instant, at time t, number of undecayed nuclei were n. So if you remove the proportionality sign, it will become dn over dt is equals to lambda into n, and this minus sign I have sent here. So this is decay law. dn over dt is equals to minus lambda, and where lambda is a constant, and it is known as decay constant. What it is known as? Lambda is called as decay constant. Very good. Now, one more relation after solving this, what we can get is another very important relation. If we solve it, it will become integration. After integration, it will become n is equals to n naught e raised to the power minus lambda t. Again, if I ask you what is n and what is n naught, n is remaining active nuclei at time t. N naught was the initial active nuclei. Now tell me, what is the meaning of active here? Two things that you need to answer. Another thing that I want you to answer is write the unit or comment the unit of lambda here. Unit of lambda you need to answer. Next thing that you need to answer, what is the meaning of active here? We have covered the chapter of unit and dimensions. In that chapter, I told you, first of all, tell me who is answering. Veena, Logesh, Ayushi, Sushant. Do you remember this thing? That power of exponential is dimensionless. Do you remember this? Power of exponential is dimensionless. That means the dimension of lambda into t is dimensionless. So what I am saying, lambda into t is dimensionless, no dimension. T has a dimension of time. So lambda must have a dimension of 1 by t, na? Only then it will be dimensionless. So lambda has a unit of 1 over time period, 1 over time, that is second inverse. That is second inverse. I hope you just forgot everything. Isn't it? Be responsive and responsible as well. So unit of lambda is second inverse. It is called as decay constant. I think till now everything is clear. Remember this formula. Remember each and everything. N naught is what? initial number of nuclei. You can directly remember initial number of nuclei. N is what? Remaining nuclei time t. Clear? Now, graph between n and t. The equation between n and t is given by this equation. So this is going to be exponential graph. If you don't know what is the graph, you can just remember, because graph is a part of mathematics. So don't worry about that. Let's suppose this is the axis representing n, this is the axis representing time, and the graph will be something like that. This is the exponential graph that will touch the time axis at infinity. This is the initial number of nuclei. This is time t equals to 0. This is at time t equals to infinity, it will be 0. Clear? Okay, very good. Moving further. Activity of a sample. Activity of a sample, generally it is denoted by either A or activity is denoted by R. Any one symbol you can choose, A or R. Now the second thing is rate of decay is called activity. Rate of decay is called activity. That means if I say activity is nothing but rate of decay. Is it clear? Activity is nothing but rate of decay, but we know that dn over dt from the previous slide, we know that dn over dt is equals to lambda n. Is it clear? What I have done, activity is what? Rate of decay. Rate of decay is what? dn over dt. And it is directly proportional to the number of nuclei present at that time. So lambda n. One thing more, we can place the value A is equals to lambda, n is equals to n naught e की power minus lambda t, where lambda into n is the activity at time t. So lambda into n naught will be the activity at time t naught. So it will become A is equals to A naught e raised to the power minus lambda t. This is another very simple term. A is equals to A naught e raised to the power minus lambda t. Same relation, n and A both have same relations. So two formulas that you should remember. One is A is equals to lambda n. Another is this one. Now the thing is, what is the unit of activity? What is the unit of activity? Activity is what? Rate of disintegration. So what is the unit of activity? Is becquerel. Becquerel, or generally 1 becquerel is equals to 1 disintegration per second. Generally, someone may call the activity unit of activity as disintegration per second. Disintegration per second means 1 disintegration per second is called as 1 becquerel. So becquerel is nothing but integration per second. There are other units on the name of some famous scientist. You know, the Curie, the husband and wife Curie. You know that Marie Curie and Pierre Curie. So 1 Curie is what? Just remember this term. It is directly asked. 1 Curie is equals to 3.710 raised to the power 10 becquerel. And another unit is Rutherford. 1 Rutherford is what? 10 raised to the power 6 becquerel. Write it down and remember it. Moving further. Half-life. Half-life is what? The time in which number of active nuclei in a sample reduces to half the initial value. This is very simple. Initially, I have n naught number of nuclei. So the time, this is at t equals to 0, the time at which the nuclei becomes half is called t half, is called half-life of the sample. And half-life of the sample is denoted by, it is denoted by t half. This is the half-life. And what is the formula for this half-life? You calculate, it will become, you don't need to remember the derivation thing. What is the more important is, what is the formula? Time or half-life is ln2 by lambda. ln2 means log base E2 by lambda. So if you solve log base E2 or log ln2, the value of ln2 is 0.693 and lambda is there. 0.693 by lambda is the half-life. Clear? One more thing. Listen. In this chapter or in this part of the chapter, formulas are very important. You cannot forget any of these relation, any of the formula, because in that situation, it's not possible. And the practice is very much required. From the last, every year, 22, 21, 29, whatever may be the year you call it, and there will be a question from radioactivity itself. And it's the chapter in your chemistry as well, I think. So one topic can cover two chapters or two subjects itself, the topics from two subjects. So it's very important. Now, one more thing that I will explain it to you. Active nuclei after n half-lives. Listen to me very carefully. Let's suppose there were n naught nuclei. After one half-life, HL means half-life. One half-life, the nuclei will be n naught by 2. Do you agree with that? Nuclei will be n naught by 2. If I say after one more half-life, the original were n naught by 2. And can you say that they will again become half after one more half-life? Very good, n naught by 4. Similarly, if I say, you can see that it is just nothing but n naught 1 by 2 square. So after two half-lives, they are becoming n naught 1 by 2 square. So after three half-lives, they will be, after again another half-life, they will be n naught 1 by 2 raised to the power 3. Similarly, on this behalf, we can say that after n half-lives, they will be n naught 1 by 2 raised to the power n. So what is the meaning? That after n half-lives, the number of active nuclei are n naught 1 by 2 raised to the power n. Now, this is the general phenomena. We are taking time as one half-life. We are taking time as one half-life. Can there be a question something like that? Listen to me very carefully now. We can remember this formula, but I am talking otherwise. What if I say that there were n naught nuclei? After 1 hour, I am not saying this is T half. I am saying after 1 hour, they are becoming n naught by 4. So after next 1 hour, they will be n naught 1 by 4 square. After another half hour, after n hours, it will be n naught 1 by 4 to the power n. So we can actually transform not only for half-life, for any time period. If it can be broken, we can solve it. We can make a relation. So it's not necessarily that 1 by 2 raised to the power n. 1 by 2 raised to the power n is happening because we are talking about half-lives. It can be in the form of n naught 1 by 4 to the power n, depending on the relation. Okay. So this is the relation. So what is n here? N here, number of half-lives. Okay. One more thing. Total time. Total time in n half-lives. What is the meaning of this statement? I said that after 4 half-lives, what will be the amount left? So 4 half-lives is clear. So total time involved in this process will be, I will say total time, let's suppose T, n half-lives, and each half-life is of T half. So this is another good relation, that total time is equals to n times of T half. N is the number of half-lives, T half is the half-life of the material, of the sample, whatever it is. One more thing. Now, after that, there is another term, average life or mean life. Okay, first of all, solve this question. This is a simple concept test for you. I will give you 30 seconds for this. Try to solve it out and give me the answer. Answer is very much required for this question. Half-life is given as 1600 years. After how many years 25% of radium block remains undecayed? Remains undecayed means remaining material is 25%. Clear? Remaining material is 25%. Okay. So let's suppose initially there are N naught nuclei, and after some time the remaining number of nuclei were 25%. 25% of N naught means N naught by 4. Is it clear? 25% you can calculate now. 25 means 1 by 4. So remaining nuclei were N naught by 4. What we know that N is equals to N naught 1 by 2 raised to the power N. Can you place N is equals to N naught by 4? N naught 1 by 2 raised to the power N. One by 4 is equals to 1 by 2 raised to the power N. So what is the value of N in the calculation? Can you see that N is going to be 2? If N is going to be 2, what are they asking after how many years? So number of half-lives were 2. They are saying total time. They are asking after how many years. That means they are asking the total time. So I have told you total time is equals to N into T half. 2 into T half is 1600. That is 3200 years. Is this question clear? For your NEET examinations, this formula is very important. Say yes or no. Is this question clear? I will move further for the mean life. Mean life. Okay, Ayushi. Okay. So what is mean life? The average life. Okay. There are lot of samples, lot of nuclei in a sample. So the average life of all the nuclei is called mean life of the sample. What's happening? Listen to me very carefully. This is a sample in which lot of nuclei are there. These all are the nuclei. Okay. Now what happens? Let's suppose this is situation at t equals to 0. As you leave the sample, let's suppose this nuclei is disintegrated just after that. And this nuclei is disintegrated after a long time. So the life of this nuclei, that let's suppose this is first nuclei, this is nth nuclei. So life of first nuclei is very small. However, the life of nth nuclei is very large. So the average life of all the nuclei is called mean life of the sample. Are you getting my point? One person is living for 10 days, another person is living for 100 years. Another person is living for 100 years. So what is the mean life of the city? In a city, I am talking, one person is dead after 10 days, one person is living for 100 years. So what is the mean life? What you do? You will do sum of the lives of all the nuclei or all the persons divided by number of persons. That's what you do. So this is the same thing with the mean life of the sample. What is the mean life of the sample is this one. The average life of all the nuclei. How you calculate the average life? First of all, add the lives of all the nuclei and then divide it with the total number of nuclei. I think statement is clear. Now, after a lot of integration things, lot of calculation, the result that is going to be achieved is mean life is denoted by tau. What is it? Tau. Tell me one more quantity which is represented by tau. Tell me one more quantity, at least one more quantity which is represented by tau in the complete entire physics. Thought. Very good, Aishi. Very good. Very good. Torque. Do you remember the formula for torque? Do you remember the formula for torque? Now let me take a test of torque. Anyone who remembers the formula for torque, is it a vector or a scalar? PE. Okay. It is a vector. PE. No, 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 Logesh. It's not PE cos theta. It's PE sin theta. It's P cross E actually. Very good, Veena. So you are telling me the formula for torque on a dipole in a uniform electric field. That's what you are answering. Very good. Very good. Okay. Now it's not torque, it's tau. Mean life is equals to 1 by lambda, where lambda is what? Lambda is what? Name of lambda is what? Okay, lambda you forgot. Lambda is decay constant. Okay, now one more thing that you know that decay constant. Very good, Chichini. Now one more thing that we know that T half is equals to 0.693 by lambda. Is it clear? So 1 by lambda, this 1 by lambda, I have sent 0.693 to this side, that is T half by 0.693. So this 1 by lambda is nothing but tau is equals to, if you divide it, it will become 1.44 times of T half. So mean life is equals to 1.44 times T half. 1.44 times T half. So remember either this or this. Both relations should be remembered, not either or. You should remember both the relations. Clear? Okay. Now, after this point, we will take some questions. Let's examine what you have learned. Try to solve. Now, you will try to solve. I will give you for this question 40 seconds. And please try to attempt. Do you have notebooks and pen so that you can write and you can solve? Okay. So let's solve it. Half-life of a radioactive nuclide is 100 hours. That means First of all, mention the data that is half-life is given as 100 hours. Okay. The fraction of original activity that will remain after 150 hours would be. So whenever they are talking about fraction, so the fraction means activity at time t divided by original activity they are asking. This is what they are asking. Clear? Or they are asking after 150 hours. After 150 hours. So you can write it as A is equals to A naught 1 by 2 raised to the power n. You have studied that n is equals to n naught 1 by 2 raised to the power n. And I have told you in the previous slide that n and a can be replaced in the formulas. So a is equals to a naught 1 by 2 raised to the power n. Clear? So a upon a naught is equals to 1 by 2 raised to the power n. Now the thing is, what is n? So for that, you remember one thing. Okay, you were supposed to answer the question now. Okay, don't look at my answer and try to solve it before me and send me the answer. So n is equals to what? Or in fact, I will say total time is equals to n into t half. You know that. So total time, they are saying after 150 hours. So total time is 150 is equals to n into t half is 100 hours. So n is equals to, you can say 0 and 0, 5, 3 and 5, 2. That is 3 by 2. So you got n is equals to 3 by 2. Place it here. A by A naught is equals to 1 by 2 raised to the power 3 by 2. 3 by 2 means, first of all, you need to cube it and then take under root. So that will be 1 by 8 to the power 1 by 2. And root of 8 is 1 by 2 root 2. Okay, Veena, you were correct. Option C is correct. Very good. So you gave the answer 2 seconds earlier than me. Very good. That is 1 by 2 root 2. Very good. Is the question clear? In this question or in radioactivity, the main thing is to collect the data from the question. I have seen students getting failed in getting the data. What's the demand of the question? They can't predict, they can't get the question. And in that situation, it is very difficult for them to answer. Next question. Take some time. I will not read, I will not speak a word till you read the question. Have you read the question? Now, I am reading it. The rate of radioactive disintegration at an instant. Okay, rate of disintegration is given. So one thing is given, that is rate of disintegration, that is dN over dt is given as 10 to the power 10 second inverse. That is given. And rate of disintegration is minus dN over dt. Next thing which is given here, for a radioactive sample of half-life is given. That means T half is again given. 2.2 into 10 raised to the power 9 seconds. Okay. So the question they are asking, the number of radioactive atoms in the sample at that instant. So radioactive active nuclei they were asking. Okay, no problem. Now, from the given data, the first thing that came to our mind is from the law of radioactive decay, this dn over dt is nothing but lambda into n. Is it clear? And this lambda into n is given as 10 raised to the power 10. Now, if I want to calculate this n, I need this lambda. And for this lambda, t half is given. For the calculation of this lambda, t half is given. And you know the relation t half is equals to 0.693 divided by lambda. So lambda is equals to 0.693 divided by t half. And t half is what? 2.2 into 10 raised to the power 9. Clear? So I will place the values here. 0.693 divided by 2.2 into 10 raised to the power 9 and is equals to 10 raised to the power 10. Now it's your task to calculate it. N is going to be 2.2 into 10 raised to the power 19 divided by 0.693. Now you need to calculate it. And after calculation, whatever may be the answer is to you. I think the power is going to be 19. If I divide it, it will be around 3. So 3 10 raised to power 19. That is going to be option number D. Power is 19 and the ratio, if I see, it is, can you see that this is 0.7? 0.693 is nothing but 0.7 and this is 2.2. So 7 3s are 21. So I am pretty sure that answer is something 3 point something and power is going to be 19. So 3 point something is everywhere, but power is 19 is in this situation only. So option D is correct. Are you getting my point? So which is correct option? 3.17 into 10 raised to the power 19. Okay. Are you able to start the question? Have you collected this data after reading? One more question we will take. At least solve this question. At least solve this question. This is the easiest question of the lot. Solve this. Seriously solve this. Be focused and solve it. Veena, Sushant, Logesh, Ayushi, Chichuni. Ritu is also there. Balveer. Can you solve this or not? Or should I start? Can you solve this or not? What I think is you don't have pen and paper. You were just lying in your bed and just taking the class. Is it? For a radioactive material, half-life is 10 minutes. When you are starting the question, and in these type of question, I am not saying, I have not said that for every question you need to mention the data, you need to write down the data. No. But for this chapter, you need to write down the data. That is T half is equals to 10 minutes. Okay. If initially there are 600 number of nuclei, whenever they are saying initially, that means you should first should come in your mind that is N naught is 600. Very good. The time taken, they are asking in a minute. That means we don't need to convert it. For the disintegration of 450 nuclei, that means 450 were decayed. So the remaining number of nuclei were 150. Is this point clear? Originally there were 600 and 450 were decayed, so remaining were 150. So 150 were remaining. So what is the time taken? Again, you can see that n is equals to n naught 1 by 2 raised to the power n. N is what? 150. N naught is what? 600. 1 by 2 raised to the power n. Can you see that this is 1 by 4 is equals to 1 by 2 raised to the power n. So n is going to be 2 again. You can get this point. Now after this to this, how we can get n equals to 2? Now after getting n equals to 2, that means total number of half-lives are 2. So total time is going to be n into t half. 2 into t half is 10 minutes, that is 20 minutes. Clear? Moving further. This is one more question. Radioactive material A has a decay constant 8 lambda. Okay, that means lambda is given as 8 lambda, and material B has a decay constant lambda. Initially, they have same number of nuclei. Okay, that means they are saying that there is a sample A and there is a sample B. Sample A has decay constant 8 lambda. Sample B has decay constant lambda. So you can say that this is lambda 1, this is lambda 2. Okay. Initially, they have same number of nuclei. That means initially they have same number of nuclei. Let's suppose this is N naught and N naught. After what time the ratio of number of nuclei of A to that of B will be 1 by E. So let's suppose after time T, there is number of nuclei N1 and there is number of nuclei N2. And the ratio of N1 and N2 is given as 1 by E. Ratio of N1 and N2 is given as 1 by E. Am I audible? Am I audible now? Okay. Okay. So now, okay, Veena. I think data of the question is clear. Now in this question, nothing is mentioned about half-life. That means the relation that we were using n is equals to n naught 1 by 2 raised to the power n is not going to be used, is not beneficial anymore. Now, the another relation that you know is n is equals to n naught e raised to the power minus lambda t. Is it clear? So for sample A, if I write, it will become sample A. After time t, the number of nuclei were n1. So that is n1 is equals to, initially there were n naught e raised to the power. Lambda is what? 8 lambda and time is t. Clear? And for second element, that is B, n2 will be n naught e raised to the power. The decay constant is lambda minus lambda t. That is equation 1, that is equation 2. Now they are saying the ratio of number of nuclei of material A to B. Ayushi is saying option B. Okay, let's check it. Is 1 by E. So N1 by E it is mentioned. So I will divide these two equations and I will get 1 by E is equals to, you can see N naught and N naught will be cancelled. That is E raised to the power. This is minus 8 lambda T and this is minus lambda T. If I take it to the numerator, it will become positive lambda T. So that is minus 7 lambda T. Clear? Can you see this? Or if I say 1 is equals to, I have transferred this E as well, E raised to the power minus 7 lambda T plus 1. How this plus 1? You know the during the product power adds. So if I multiply E here, then it will be minus 7 lambda T of power is already an E raised to the power 1. So 1 will be added. Now take log of both sides. If I take log on both sides, what it will become again? ln1 is equals to, I have taken log base E. So log base E, if I take, then E will be cancelled. That is minus 7 lambda T plus 1. Clear? So ln1 is nothing but 0. I think you have studied something about log in your basic class, 7th, 8th or 9th or 10th, whatever it is. So from here, you can see that 7 lambda T is equals to 1. So T is equals to 1 by 7 lambda. T is equals to 1 by 7 lambda, which is option number A. Ayushi, you have made some mistake, I think. You have made a mistake. This is not B, this is A. Identify your mistake. So this question is nothing but simple calculation. Okay, very good. Now, there is one more question for you. Read it out. The half-life of radioactive isotope X is 20 years. Okay, tell me what is isotope? What is the meaning of isotope? I have told you na in previous class that read about isotope, isotones, isobars, and isomers. It decays to another element Y, which is stable. Okay. So they are saying number of protons. Very good. There is an element X. Very good, Chichuni. There is an element X. It decays into Y. Clear. Y is stable. The two elements X and Y were found in the ratio X and Y were found in the ratio 1:7. Very good. And the half-life of X is 20 years. That means T half is equals to 20. What are they asking? The age of the rock is, what will be the age of the rock? Now listen very carefully. The half-life is 20 years, X is converting to Y. So after some time, they have seen that the ratio of X to Y is 1:7. That means, what is the meaning of this fraction? That means out of 8 portions, 1 portion is of X. Out of 8 portions, one, if you divide the sample in 8 equal portions, so out of those 8 portions, 1 portion belongs to X. What does it mean? The quantity of X is nothing but 1 by 8. Quantity of X is nothing but 1 by 8. I am taking this as if initially there were only one, initial number is 1, or you can say this is N naught by 8. Okay, I'm explaining this again. The ratio of X and Y is 1:7. Okay. So if I go with the basics, then let's suppose X is, you can take any number. Let's suppose this is X, this is 7X. So total were 8X. So initially, when the sample was made, when the rock was made, initially there were 8X elements of X. Now there is only X elements of X. Initially, N naught is 8X and final element of X is this one. The ratio of N over N naught is 1/8. So I am not recommending this to you. What I am saying, if the ratio of X over Y is 1/7, that means X has one portion out of total 8 portions. So the value of X at time t, the value of X, you know the formula, N is equals to N naught 1/2 raised to the power N. You know this relation. So N by N naught is equals to 1/2 raised to the power N. So question says N by N naught is the ratio, is the value of element X. So this value is nothing but 1/8 is equals to 1/2 raised to the power N. I am repeating my words again. What I'm saying, the ratio of X and Y is 1/7. That means X is what? 1. Out of total elements were, total particles or nuclei, whatever you can say, total were 8. So this is total, this is remaining. So N over N naught is what? 1/8. Remaining was 1 and initial was 8. If this ratio was 2:7, then what you will say, that remaining nuclei were 2 out of total nuclei were 9. If this ratio was 1:4, I am telling you what is the meaning of this. If the ratio of X is to Y is 1/4, that means remaining nuclei of X is 1. That means N is equals to 1. And total nuclei were 5. That's how you can calculate these things. I am deleting this. Okay. Now you know the terms. Just place the values and you will get the answer. So N is equals to 3. This is 1/2 raised to the power 3. So N is equals to 3. So the age of the rock is total time that will be taken for this much remaining number of nuclei is N into T half. And N is 3, T half is 20 years. So that will be 60 years. This is a very famous question, I will say. Or you can say this is an important question. This is going to be the important question. Okay, Chichuni, tell me, is this ratio thing clear? X and Y, but total is 8X, na? Okay. Now we will take some examples on nuclear fission and fusion. Okay. I have told you in the previous class or yesterday's class that what is fission and why it happens when nucleus becomes unstable. I have drawn a graph of binding energy per nucleon curve, binding energy curve I have drawn. So what happens when a nucleus splits into two smaller nuclei? Then the two nuclei are more stable as compared to the parent nuclei, and in the process some energy is released. because loosely bound is converted into a tightly bound material, tightly bound nucleus, and in this process, some energy is released. So the example for this is generally the fission of uranium is very famous in your class. Uranium is has so much isotopes, many isotopes you can say. Out of this, uranium 235 gets fissioned by neutrons, or you can say slow neutrons. What happens when we strike thermal neutrons? These are called thermal neutrons or slow neutrons. These are called thermal neutrons. Okay, I will delete it. The uranium converts to its another isotope, that is 236, and this 236 can be fissioned very easily, or it fissions by itself. It is highly unstable. So uranium 236 is highly unstable element, highly unstable nuclei, and it breaks into these two elements, barium and krypton. But it is not necessary that it will break in these two components only. It can break in another two components, another particles as well. So no problem with that. And in the whole process, three neutrons were ejected. This is wrong. Three neutrons were ejected. And these are called fast neutrons. Fast neutrons means they possess lot of energy. So what's happening here? Uranium 235 is strikes or it is being striked by the neutron, which is thermal neutron. It converts to uranium 236, which is highly unstable, and it further breaks into two components, barium and krypton, two nuclei, barium and krypton. But I am saying again, it is not mandatory that it will break in these two elements only. But the probability of these two elements is very high. It's not necessary that it will break in these two elements only. Mark my words. And in the process, three neutrons were released, which have a lot of energy, and these are called as fast neutrons. And in the process, some energy is also released, and this energy is of the order of 200 mega electron volt. Of the order of 200 mega electron volt by fission of one nucleus of 235. Mark my word. In a sample, there are millions of nuclei of 235. So you can estimate the amount of energy that is going to be released, and this is the basic phenomena behind the nuclear bomb. Behind the nuclear bomb. Okay. Nuclear fusion. The opposite of that process is nuclear fusion. Out in this topic, fission topic, what you should revise by yourself is nuclear chain reaction. Just have a look from your notebook or from your NCERT book. And another thing is nuclear reactor. Clear? Read out these two components, these two topics from your NCERT book, and it will be enough. What are moderators? What are control rods? Why hard water is used? So you can read out these topics from this nuclear reactor topic of your NCERT book. Okay. Nuclear fusion. Nuclear fusion is what? Two light nuclei combine. But for this to happen, we need some extra energy and lot of energy and high temperature for this to happen. And this is called nuclear fusion. Again, you can see that these are the two lighter nuclei combining to give one heavier nuclei. And this nuclei again combines to give some isotope of helium 2He3. And in this process, lot of energy is released. One more thing that I will tell you, listen to that thing only. In all the processes, whether it's fission or fusion, some energy is released. Mark my words now. Some energy is released. And this energy is what? Mass of reactant minus mass of product into C square. Another thing, another thing, for a fission or fusion reaction to be correct, I have mentioned a fusion reaction for you. I have mentioned a fission reaction for you in the previous slide. So for a fusion or fission reaction to be correct, this Q value must come out to be positive. It must be positive. It is must that Q value is positive. If Q value is negative, if Q value is negative, then the fission and fusion is not possible. Are you getting my point? Then fission and fusion is not possible if Q comes out to be negative. So Q must be positive, or can you conclude that if Q is positive, that means mass of reactant should be greater than mass of product, should be greater than mass of product. Clear? So on behalf of that, there is one question. Can you solve this question? Can you give the answer of this question? This is M1, you can say. 1 should be in subscript, M1 and M2. In a nuclear fission fusion process, the masses of the fusing nuclei be M1 and M2, and the mass of the resultant nucleus be M3. Then what will be the correct relation? M1 and M2 are the two nuclei which get fusioned, which get fused, and resultant is M3. Okay, Veena is saying C. Very good. The thing is that mass of reactant should be greater than mass of product. So mass of reactant should be greater than mass of product. So which is option number C. Option number C. Very good, Veena. This is the end of the session. Bye, everyone. Thank you.